Next up is our presentation on open standards-based framework for audio metadata transport and live content workflows, presented by Kent Terry. Kent is a senior manager, sound technology, Dolby Laboratories Office of the CTO. He joined Dolby in '92 and has worked in a variety of positions in engineering and research. He was a key member of the team that developed the Emmy Award-winning Dolby Digital System and build the first working prototypes for the ATSC 1.0 standard. In addition, he was part of the team that developed Dolby E for distribution of multi-channel audio and broadcast networks. Other areas Kent has been involved in are lip sync and the development of voice technologies. His current focus is expanding support for advanced audio services and live production environments, including standards for audio and audio metadata over IP. He is active on SMPTE standards committees, and he has been a key contributor to several SMPTE standards over the years. He holds a Bachelor of Science and a Master of Science degrees from electrical engineering, both from the Georgia Institute of Technology, and is a member of the SMPTE and AES. He is recipient of the 2011 SMPTE Journal Award for his paper, Detection and Correction of Lip Sync Errors Using Audio and Video Fingerprints. Please give a warm welcome to Kent Terry.
Hey, good morning. So yes, I'm not here to talk to you about metadata. I'm here to talk to you about transport of metadata. So that's my focus within Dolby, is getting metadata around, and the specific focus at this point is on live workflows. I'm going to talk a little bit about that in the standards-based thing. And I was going to give you, we talk about things when we're talking about the big picture, the vision for the future, but we're talking about sound, so I'm going to give you the big sound, not the big picture. For a start, one of the things we're focused on right now is enabling where things are going for audio in the future. And so the immediate focus is on ATSC 3.0, since we're talking live and broadcast, and the codecs that are part of that and their features, AC4 and MPEG-H, and all the features that they're capable of supporting. What do we need to do to enable those features in live production workflows? But we're also looking at more advanced applications like VR and AR and a variety of others that may come in the future, and features like immersive audio, more spatial aspects, personalized, all these different things. What do we need to do in live production to enable these? The common thread for all of these is dynamic metadata is essential, like Peter said. That's the way the world is going. Simply more channels is not the future of audio. It's the metadata about the audio is where the innovation is happening. The other observation about that, my experience over the years, is that it's very hard to predict what metadata you're going to need in the future. We've done a very bad job of predicting what we need. We either define metadata we don't need, or we don't find metadata that we do need. So it's a constantly evolving process to add new metadata and, when possible, stop sending old metadata that's not needed anymore. Loudness is a good example. Loudness metadata is constantly evolving and changing, and being able to keep up with those changes is important. Another observation is in the file-based world, these methods are maturing. Cinema is a good example. Cinema makes regular use of object-based audio now in spatial terms. They don't use all the personalization features, but they have a very metadata-centric audio workflow, and it works very well all the way through the chain to distribution, to production, to display. And it shows you what you can do in delivering a product with these. And there's no reason broadcast can't do this. It's there. And we're already doing it with over-the-top methods for people like Netflix and others. A file-based workflow, those tools are well more advanced than live is at this point. And it shows you the potential where things can go. So our goal is, the big overriding goal that we see is we want to enable microphone to speaker metadata. And what do I mean by that? This is an example workflow. We have a variety of inputs that feed into a production, the mixer that makes the production that goes to the consumer. That goes through a distribution path, which may involve storage, goes to some kind of codec that forms it for distribution and emission to the consumer. It can go through a variety of paths these days, traditional terrestrial, or the cloud, or the web, and it goes to a variety of endpoint devices, not just TVs, tablets, headphones, all sorts of things. So what we would like is a way to maintain metadata throughout this entire system. So for example, let's say we have a specialized microphone that captures spatial characteristics. We might want to carry that metadata all the way through a system, through a live chain, maybe through storage, and over terrestrial, to a headphone device, and that end device can make use of that metadata. Or say we have a live sporting events and there's a commentary channel. We'd like that side commentary channel, which may be delivered through the web to a TV, so the end user can have that side commentary. It may not even be part of the main program. So that's an example. These are examples of where we'd like this kind of metadata. So what I'm going to focus on today is this portion, the live production portion, where we talk about what's essentially a finished program, how that gets through live production to the point of emission. So the current state of where we are. Today, most live broadcast audio the vast majority is channel-based 2.0 or 5.1. There's some things coming in the future, but right now that's kind of where we are. There's limited support for dynamic metadata. There's standards, some people use it, but it's not a widely used thing. You can certainly have channel-based workflows without metadata, and many people do. There's been a lack of cohesive standards in this area. We do have standards, and I talk about them in the paper, that exist for sending live dynamic metadata, but they're limited in their capabilities, they're limited in their distribution paths, and the paper goes into some of the details of what their issues are and where we might need improvements in the future. And right now, of course, we have very limited support for more than 5.1. There are certainly examples where we're doing more than 5.1 in live workflows, and particularly like Japan, they're doing things with 22.2. We and Fraunhofer are on the air in various places with new immersive formats, but these are, just the start of this, and right now they're being implemented in very non-standard ways. And so we'd like to get standards to evolve so that we can enable these to grow in practice. The other thing that's going on in the industry is a big transition, as many of you know, from traditional legacy interfaces, SDI and AES3, to IP-based transport. So that's a big consideration to keep in mind. So when we're looking for the requirements of what we might want for next generation transport, these are a few of them. I categorize these in terms of what features do we need in standards that support this. And for a start, the functional needs, we need to support all of the needs for live production that we currently do today. We need low latency for live. We need to be able to support switching like we do today with audio channels, and synchronization, and particularly when we go to this new IP future, keeping everything properly synchronized, both lip sync as well as synchronization of timing clocks. All that needs to work with metadata. And as I mentioned, we need something that can evolve, that a metadata format cannot be fixed, saying here's a monolithic metadata structure and it's a standard and it's fixed. We need something that's expandable and open. Standard metadata is a very, very important part of the future, but we also realize that non-standard metadata, including data that's not even publicly disclosed, is an important part in enabling functions in actual products. Both need to coexist, and we need transport methods that support all these kinds of data. We also have to keep in mind the bandwidth of the data, both average rates and bursty rates. Metadata can be bursty, particularly when you're dealing with dynamic objects. So we need to keep these in mind. File interchange is very important. Something that's strictly live is very rare these days, and everything is going to be at least cached. And going to and from file formats is very, very important, and we want a transport mechanism that can support that functionality. And we also, of course, need something that works on today's systems as well as forward-looking to the future of where we're headed with broadcast and live workflows and transport. And finally, we want it to be, as much as possible, standards-based, both for interoperability and from a standpoint of somebody who works on standards, I'd like to avoid creating new standards wherever possible. Then the big takeaway I want to say with this, the whole point of doing this is not just so vendors can sell products, it's so that broadcasters and other providers can enable new services to keep consumers excited. The whole point of this is that we can continue and evolve and remain competitive, and so that live production and live workflow can give features that are of interest to end consumers and keep them interested. So I'll briefly talk about this. When I mentioned the different portions of the chain, one piece of the chain is delivery to the consumer, and on the side that we've worked on, AC4, there's a format for doing that. It's called the Extensible Metadata Format, EMDF, and it's defined in the AC4 ETSI standard. And this is an open transport method for sending time-synchronous metadata grouped into what we call payloads, and it's flexible about what that means. But you can define a payload, and you can register a payload with this format and send it along with the audio, and it can be delivered synchronously to the end device. And it supports timing, it supports all the things you need to keep metadata aligned with the audio. And it's extensible. It's open, and we've in fact started a new registry for that. You can see the website for it. Then anybody can go and request a registration of their data type to go through this. So it fits in with that model of allowing metadata to evolve over time. So the question we had was, this is a great format, but can we apply this to live production? And when we looked initially at saying, well, can we carry this EMDF over into the production workspace? There are a number of reasons why that's not a good idea, because this is a consumer format, and a lot of the features it's needed are very specific for that. And there's other methods too. So we said, well, what can we do that's similar to this, but meets the requirements that I outlined above? So what we're proposing for this is to use, in the spirit of utilizing existing standards, base something on KLV. And as many of you probably do know KLV, it's a basis for a lot of file-based things, but it was always intended for live use cases as well. And so, you know, SMPTE, it's a long-term SMPTE standard, 336, and it stands for key length value, and there's lots of tools that support this, it's particularly in the file-based world. So what we're proposing is we send data in a structure that has a universal label. It's all part of the SMPTE metadata registry. And we send audio metadata that are in payloads, and what these payloads are themselves KLV packets. Now the key to that is it has a universal label, so it all gets defined in the metadata dictionary, but what the metadata itself is open. It doesn't have to be part of the metadata dictionary. It can be its own structure, and that's very important. So it can be KLV, but it can also be plain text, it can be XML, it can be efficient binary streams, whatever it needs to be. And so what we're working on is defining a structure, a standards-based structure for implementing this and being open to what these payloads are. And the first step in that direction is SMPTE standard ST2109, which is currently in development. And this is specifically focused on defining metadata transport in AES3. And where this is headed right now, and it seems pretty far along, is using this KLV structure to send it over AES3, and it happens in the spirit of utilizing existing standards. There's already a standard that defines that, so we're just putting constraints around that existing standard 355 that say how to map this specific metadata into the generic KLV transport. And we're using the KLV as a wrapper, as I said, so the metadata itself does not have to be KLV. It can be, but doesn't have to be. That can make it very efficient. And again, building on this metadata dictionary. Believe it or not, what a novel concept to use the metadata dictionary to send metadata, but there's not universal agreement that that's the way to go. But we think that's a good idea, and it allows for sample accurate transport of live dynamic metadata. And as I said, it's currently work in progress in the 337DG. So how does this look in practice? So here's the standard we're defining that utilizes the existing standard and allows us to get this metadata in a payload-based format into AES3. And because we're leveraging that transport mechanism, we can use a variety of existing standards to get those into interfaces. Of course, it maps directly into AES3, but also via these existing standards, we can map into SDI and MPEG-H transport. And so for current workflows, it's a very efficient way of getting relatively high bandwidth metadata through these systems. And if you add PCM audio can flow right along with it. So now we have a solution for today's workflows with PCM audio with dynamic metadata support. That's what 2109 is all about. So what about the IP future? Where are we headed with IP? Oh, I should mention the data rate, by the way. That's the available data rate if you use all 24 bits of the data word. Like 337 utilizes a sample word, so you have up to 2.3 megabits a second, which is, for metadata, pretty high, but we do have to take into account burst rates. So in the IP world, we can also leverage this via existing standards. So as I said, take 2109, goes into AES3, and via 299, that can go into SMPTE 2022-6, so we can get it in the SDI over IP format. We can also get an MPEG transport over IP, so these are ways of getting into IP transport. And in regards to the 2110 suite, the solution that's arisen is in development and now going out for ballot is SMPTE 2110-31, which is a method to define specifically AES3 over IP, and that was needed specifically to support non-PCM data for things like codecs, but it also happens to be an excellent way to get the metadata through this system via this standard. So 2109 will work with all these existing, evolving, currently being defined IP transport standards via 2109. And as I said, will flow along with PCM audio, just as in the legacy case. There's only one issue in regarding 2110 IP transport. As I said, that has maximum capability, but the method of carrying audio in 2110 is really -30. It's not -31. -31 was developed for cases that require full transport of AES3, but the future is 2110-30, which is based on AES67. And the problem is that doesn't support the non-PCM data, so we have this kind of weird situation. It's like, if you really want to use -30 for your audio, you have to send the metadata separately in a -31 stream. So it's not as elegant as we'd like it to be. And we also have this fact that we're constrained by the AES3 channel. And in the short term, I don't think that's an issue, but in the long term, relying on this fixed rate legacy interface channel as the solution for carrying metadata is not ideal. So what we proposed for the future is to carry audio via the 2110 suite as -30, as is defined, and take what we're defining in 2109, the KLV framework itself, but instead of mapping it to AES3, we utilize another existing standard, which happens to be in the ITF, a particular RFC, that talks about mapping KLV to RTP streaming, RTP streaming being the other types of streams that the 2110 suite uses. And we further think that it would be a really good idea if we could define that for use with AES67. And hot off the presses, I've just been to the AES conference last week, and we actually have a project to do that. And it's project AES-X242. So we have an approved project that's underway in AES to define this exact mapping. Now, it may not use KLV, that's to be defined in the standards process, but that's our proposal on the table that we do that. So if that happens, we have a nice solution for carrying dynamic audio metadata with all AES67 applications. Then we can take that back to SMPTE and say, SMPTE, put your constraints around it to make it work in the 2110 suite. And so we have an additional standard that can now map native audio metadata directly to IP without going through the transport of AES3. It's free of all those legacy constraints. The other advantage of this is KLV, as it's the basis of many file formats, is well suited to file interchange. And again, I haven't talked about the metadata in it, and that's a big thing. A lot of these things Oliver's going to be talking about. It would be nice if we could define metadata that goes within this transport structure that goes to and from file formats quite easily. So the last thing I want to talk about is some examples of how to use this. And again, we would love standards to do this. We're looking at supporting the ADM standard in this so it can flow through the system. Again, full support for immersive audio formats. But for some of our current applications, particularly with AES3, we need to define some metadata that's very, very efficient. And so these are some examples of payloads we've defined for current use. And we may not use these in the long-term future, but right now they're getting us on air, helping us to get on air, and they're useful things, but it gives you an idea of what you can do with this payload concept. So we've broken down the metadata into these classes that are specific to the kind of metadata it is. And you can see like one of them is specific to loudness, so all the loudness metadata would go into that thing. For moving objects, we have a payload that's dynamic objects. And so it separates them out so you send just what you need when you need it. So for examples of how this can be used in use cases, this is a use case for live immersive sports that's similar to what we're doing today. And in this one, we're sending a channel-based bed that's 10 channels with some height. We're sending 4 monologue dialogue tracks. And you can see the total number of channels we need is 16. So it has 10 bed channels, 4 objects, and 2 channels for the metadata going through AES3. And this gives you an idea what the bit rate is. These are if you add up the bytes per payload, and this assumes, in this case, to support switching, we send this once per video frame. That gives you an example. So if you look at the bit rate, That's pretty low. That at a 30 frames per second video rate, if you send it 30 frames a second, you end up with, well less than 50 kilobits a second, which is a small portion of the AES3 capacity. So that's great for AES3. However, if that's all you're sending in AES3, you're sending, a total bit rate of upwards of 3 megabits per second just to send a measly 42 kilobits a second. So it's not very efficient. But it works, and it works with existing workflows, and that's great. This other one's based on audio, slightly different case, but you can see here the data rate is still fairly low. In this case, we are sending some dynamic objects. In this case, what we're doing is we're sending the dynamic objects 4 times per video frame. So the start of the video frame, you can send a full description of the program, and then you can update the position within that. And so if you add up the total, you're still within a quite reasonable range. And we think for efficient carriage of metadata, this is a nice example. And the third one is a much more expansive one where we're sending several groups, several different programs and different spatial groups with different languages. And in this case, we're sending a total of 32 audio channels that would be Mezzanine encoded, for example, with our Dolby ED2 coding. And we also assume in this case that we're sending the metadata in the stream with the coded audio. So this is an example where we're applying, the 2109 format is agnostic as to what form the essence is in. So in this case, we're sending it with coded essence. And in this case, it's a higher data rate. We're still sending this dynamic updates 4 times per video frame, and you can see the total's gone up, but it's still, just over 10% of the AES3 channel capacity. So it's a very efficient structure for sending this, and we've tried very hard to keep the structure in this 2109 KLV format very efficient, so it has low overhead. And so these data rates do include that overhead. So to sum it up, basically the takeaway is, and what I'd like everybody, certainly in this room, and if everybody you talk to is metadata is the future of audio, and as the longer we go into the future, the more of a requirement it is. It's not an optional thing, but we really need it to have these new audio features and these new audio services that keep end users interested and keep being competitive with what over the top and other applications are doing. Right now we lack cohesive standards, and that's the focus of my work now, is to get standards in place to enable this transport and enable these things we need in the future. And what we've proposed is a model for an open framework based on that. We're leveraging as much as possible existing standards, creating new ones where needed, but trying to leverage it. Like I said, having a standard that can leverage both, support the AES67 community at large as well as SMPTE needs is an example of a very efficient standard. If we can do that, that's great. In fact, they're interested in working with SMPTE. Certainly there'll be liaisons, but we possibly could form a joint task group to work on this. So that's what I mean by efficient standards, utilizing existing ones and leveraging standards across multiple platforms wherever possible. The solution we've had also looks at that we proposed also addresses a solution that works today but also works in the future. The same KLV structure we use in 2009, you can take that same one and map it to what we see as the native IP future. You can map it either via tunneling or you can map it via this new standard we're developing in the AES, if we can follow that same model. So it can flow back and forth between the two systems. Eventually IP will take over, but that'll be many years from now, and we'll still have this need to transfer back and forth between the systems. And again, file interchange, that we think KLV is a nice structure to support that, but the metadata itself is still a big open question, so a lot of work needs to be done at that to maintain that. And I think what Oliver's going to be talking about is a step in the right direction with that. If we can enable such metadata with live transport, then it's a big step in being able to go seamlessly back and forth between live and file-based. And again, 2109 is a first step in meeting these needs, and I've described what we're doing with AES and others to do the step beyond that. So what I'm here to present is our ideas and where we're currently at in the standards process, but I'm also having a call for support too, that we need help making this work. 2109 still needs to get out of committee and into ballot and get into practice. And it's not just 2109 that we do see the need for other standards and recommended practices to talk about the kinds of metadata you put there. That 2109 is just the format for the transport, but for specific applications, you're going to need to constrain the metadata and describe how you put it in 2109, how you receive it, how you interoperate. And so I think there's going to be a lot more work needed in that area to talk about the actual metadata we transport. And this follows the model that we developed years ago for 337. 337 just describes the basic data burst structure, but every time you want to put a new data type on there, you need to define how you carry that data type in 337. And we're doing it in a generic way for 2109, but as we get into specific metadata, I think we'll need some other standards to go with it. And I think we not only need to define the IP standards, but there's many questions I have about how audio itself, as well as metadata, is going to work in this new IP future, how switchings and transitions are going to happen. The proposal we've made is that the metadata is not sent jointly with the audio, it's sent separately. And keeping that audio metadata synchronized with the main audio, with the PCM essence, as well as associated with it, so you know the two exist, and when a receiver gets it, it knows that the two are associated, is going to be essential. So I think there's a lot of practical work we need into testing that, as well as the standards to go along with it. And this has been a big need for years and years, and I think we have the ability to do this, is metadata standards for channel labeling and identification, so we know what we have, and Oliver's going to talk a little bit about that, but that's a big one that's been needed for years. And if we can have that feature so that anytime we see an audio channel in a live workflow, we know what that channel is and we know everything we need to know about it. You know, what its videos associated with, if it's part of a bigger program, what the label is. We need standards to do that, and I think that's a big current one to focus on in the standards domain. And again, all the metadata that goes with this. ADM, one of the things that's happening in the ITU is they're working on defining a serialized version of that would be targeted for live workflows, and that's an example, but there may be other metadata, and certainly SMPTE may have specific metadata needed in production, and so I think standards to define all that are a very good place to focus on as well. And again, this interchange, I think we need some standards that cover how we do interchange of this live and file-based, because what I'd like to see in the future is really when we move to this IP cloud-based model, that live and file-based are really virtualized, that it's all seamless from the point of the operator, and we can go back and forth between file-based content and live content, and to the operator it'll all look like a flow. And I think long-term that's what we'd like to see to support. So that's an overview of where we are, and certainly if you have any questions, I'm happy to answer them, but I'd welcome any participation, any support we can get on the standards work and helping us develop all this. So thank you.
Thank you very much, Kent. We have time for maybe one or two questions. Just tell us who you are.
Hi, hey Kent.
Hi.
Scott Smyers with DTS, obviously. Okay, I had actually a lot of questions. I'm sure we'll talk offline at length over the coming months and years. But there's one question I had about your presentation today about, it's all about registration authority, and I went to EMDFRA.org, and it looks like a registry for, you can request entries in a table in the AC4 ETSI spec. Is that a correct characterization?
Yes, that one's specifically targeted at AC4 ETSI.
Okay, and is there another registration authority managed by SMPTE? Because of course the AC4 ETSI spec is not independent of codec itself.
Yes, that's why I said it wasn't appropriate for live transport and production. So as part of the 2109 process, I mean, it's going to leverage the metadata dictionary. We might, based on the work that's been going on in the standards group, we might be creating a separate registry for mapping those to tags that gets into some of the KLV issues. But everything that will be carried in 2109 will need to be defined in the metadata registry. And of course, you know, private and experimental payloads, you don't have to go through the registry process. But any standard metadata would have to have a universal label through that mechanism.
Okay, and
so
the RA you're thinking about would be in SMPTE?
Yes.
Okay, thank you.
So yes, that's the AC4 is strictly for emission, has nothing to do with the live port. We are supporting those payloads in the EMDF, in the SMPTE one, but not via that registry. That's a whole separate thing. So.
Okay, great. Thank you.
Sure.
Okay, final question quickly.
Zaidan Alawi from Cisco. Question regarding if you considered using ST11040 to transmit ST109, like something similar to what's being done with ST2020.
Yes, we can, but as you know, the S21-1040 is based on video ancillary data. So
Yeah, putting the metadata in the ancillary data.
you can do it. In fact, there's also a standard for mapping KLV into that. So you could take that same container and map it in there. But for a number of reasons, we've had mixed results in transmitting audio metadata over bank space. And if you look in the paper, there's some standards for doing that. So we've had mixed results in the future. We also think, similar to AES3, it's a lower bandwidth pipe. You can extend the ANS packets, but the ANS packets themselves are quite small. And trying to transmit this metadata and map it to a video-centric format, we don't think is a good idea. It can be done, and if it's a user need, we can define a mapping just like we do to AES3. But we think AES3 is the better solution, so -31 rather than -40.
All right, thank you.
Sure.
Thank you very much, Ken.